So once again, good afternoon, everyone. Wishing you happy Independence Day. I am Shriya Verma, editorial head at CCET ACM Student Chapter. So I hope that you had an amazing discussion yesterday regarding different perspectives one may have during his or her undergraduate journey in computer science. Continuing the same moment and energy forward, I would like to welcome you all who have turned up for this day 2 of Tech Weekend that will be focusing on the insights of data analysis and sewing code with pthreads. As we have heard a lot about what ACM has done in the past events, so I won't take much time to tell you what ACM is or the activities, but would definitely like to mention what ACM does to us, apart from providing a global community for computer science and technology. These primarily include the opportunities for networking with industrial people, researchers, and educationists, be it through the student chapter, special interest groups, or as of now with different communities like IKDD, whose event was held in the morning shared with you before. Also, about the learning experience, there are summer and winter schools specifically for top 40-50 Indian undergraduates and graduates and industry persons. They are amazing in case your domain matches with them. Since the past, our members have been selected in it as well, and this time I feel obliged to inform you that Anshul, chair of CCET ACM Student Chapter, was one of them. So, we have been growing really well in the recent past, and I've always loved working with more tech-savvy individuals who are ready for not only learning, but also to share their experience and knowledge of their domain with other budding technocrats. Also to add what Kriti mentioned yesterday, that we are working on research, coding, web development and designing. But being the editorial head for the chapter, beside all these, I want to bring into the picture that we have launched the official magazine of CCET ACM titled Digital Outlet this June, whose issue 2 will be out anytime soon. In this magazine, we have covered every possible activity and specifically we have focused on the technology. So in case you want to try your hands in writing and stuff, you can send your articles with a word limit of 500 to the email ID acmcct@gmail.com or acm@ccet.ac.in. Also, if you have any queries and suggestions, you can contact us through these emails. So, with that said, I would like to invite today's team of hosts for event 1, that is Insights into Data Analysis, comprising Parneet Kaur, Sukanya Verma, and Soumya Sharma. The platform is all your guys, and I hope that you make the best out of it. Over to you guys.
Thank you so much, Shreya. Okay, so good afternoon, everyone, and a very happy Independence Day. So first of all, I'd like to state a quote by Carly Fiorina. The goal is to turn data into information and information into insight. Today, we'll be talking about insights into data analysis. I am Praneeth, a third-year student at computer science. I'm interested in Python. I have done a couple of projects on REST APIs in Python. Also, I'm interested in machine learning and data analysis.
I am Sukanya Verma, a second-year computer science student, and I am passionate about Python and data analysis.
Hello, I am Soumya Sharma, a second-year computer science student with a keen interest in Python. I see myself as a professional data analyst in coming future.
So to start with, first of all, we'd like to acknowledge that this project showcased in this session has been made under the able guidance of Mr. Sudhakar Kumar, Department of Computer Science and Engineering. This project is supervised under me. It is a combination of seniors and juniors' contribution towards data analysis using Python. The project tells us how the students' performance can be analyzed based on different factors and variables like parental level of education, groups, etc. This project deals with the data of about 1,000 students, which gives us an idea about how to work with a large amount of data. Before beginning our session, we'd also like to thank ACM Student Chapter for providing us a platform to showcase our skills. The major topics for today's discussion will include what is data analysis, what is data visualization and its types, application of data analysis and tools used for the same, major libraries and functions, followed by project display. So as this image pops up, everyone knows what Amazon is. It is the leading e-commerce platforms. Apart from offering online shopping, Amazon serves us with its different services like Amazon Pay, Amazon Pantry, Amazon Web Services, and many more. For a company like Amazon, the amount of data collected on a regular basis is very big. Amazon is a leader in collecting, storing, processing, and analyzing personal information from every customer, which the customer as a means of determining how customers are spending their money. The company uses predictive analysis for targeted marketing, which helps them in increasing customer satisfaction and getting loyalty in return. So first of all, we'll be talking about personalized recommendation system. Amazon is a leader in using comprehensive collaborating filtering engine, which is CFE. The company follows the concept of behavioral analytics. It analyzes the purchasing patterns of the customers from the previously purchased items in the shopping cart or on their wish list, the products reviewed and rated by them to the most searched products. This information is then used to recommend additional products the other customer purchased while buying those very same products. For example, if a customer adds a mobile phone to its shopping cart, mobile phone cases are recommended for purchase. In this way, Amazon's big data uses the power of suggestion to encourage impulsive purchases from a customer and further enhance the whole shopping experience. This seems to pretty much work for the company as it generates 35% of its annual sales using this method. The next is anticipatory shipping model. Amazon's licensed anticipatory shipping delivery model additionally utilizes large information for anticipating the items the customer is probably going to buy, when he/she may get them, and where he/she may require it. The things are then shipped off a neighborhood circulation focus on stock rooms so they will be prepared for transportation once the customer requests them. Now let's see a short video regarding the same. Now, the term that we saw throughout the video was big data. The term big data refers to the data that is so large, fast, or complex that it's difficult or impossible to process using traditional methods. Big data is a term that describes the large volume of data, both structured and unstructured, that business needs on a day-to-day basis. But it's not the amount of data that's important. It's what organizations do with that data that matters. Big data can be analyzed for insights that lead to better decision and strategic business moves. Now let's understand how this data is analyzed and what actually is data analysis. Analysis refers to dividing a whole into its separate components for individual examination. Data analysis is a process of obtaining raw data and subsequently converting it into information useful for decision making. Data is collected and analyzed to answer questions, test hypotheses, or disprove theories. Data analysis is a process of inspecting, cleansing, transforming, and modeling data with the goal of discovering useful information, informing conclusions, and supporting decision-making. Data analysis has multiple facets and approaches encompassing diverse techniques under a variety of names and is used in different businesses, sciences, social sciences, and other domains. In today's business world, data analysis plays a major role in making decisions more scientifically and helping businesses operate more effectively. Now, as we have got a basic idea what is data analysis, let's go through the steps of data analysis. The first step is define why you need data analysis. Before getting into the nitty-gritty of data analysis, a business will need to define why they're seeking it in the first place. This need typically stems from a business problem or a question. Some examples which may include would be, how can we reduce production cost without sacrificing quality? What are some of the ways to increase sales opportunities with our current resources? Do customers view our brand in a favorable way? In addition to finding a purpose, consider which metrics to track along the way. Also be sure to identify sources of data when it comes time to collect. The next step is data collection. After the purpose has been defined, it's time to begin collecting the data that will be used in the analysis. This step is important because whichever sources of data are chosen will determine how in-depth the analysis is. Data collection starts with primary sources, also known as internal sources. This is typically structured data gathered from CRM software, ERP systems, marketing automation tools, and others. These sources contain information about customers, finances, gap in sales, and many more. Then comes secondary sources, also known as external sources. This is both structured and unstructured data that can be gathered from many places. For example, if you're looking to perform a sentiment analysis towards your brand, you could gather data from review sites or social media APIs. The next step is data cleaning. Once data is collected from all the necessary sources, your data team will be tasked with cleaning and sorting through it. Data cleaning is extremely important during the data analysis process, simply because not all data is good data. To generate accurate results, data scientists must identify and purge duplicate data, anomalous data, and other inconsistencies that could skew the analysis. Also, 60% of data analysts say most of the time is spent in cleaning the data, which clearly states how important this step is. One of the last steps in data analysis process is, you guessed it right, it's analyzing and manipulating the data. This can be done in a variety of ways. One way is through data mining, which is defined as knowledge discovery within databases. Data mining techniques like clustering analysis, anomaly detection, association rule mining, and others could unveil hidden patterns in data that were previously visible. There are also business intelligence and data visualization softwares, both of which are optimized for decision makers and business users. These options generate easy to understand reports, dashboards, scorecards, and charts. Data scientists may also apply predictive analysis, which make up one of the 4 types of data analytics used today. Predictive analysis look ahead to the future, attempting to forecast what is likely to happen next with a business problem or a question. The last step is interpret the result. The final step is interpreting the results from the data analysis. This part is important because it's how a business will gain actual value from the previous 4 steps. Interpreting the data analysis should validate why you concluded one in the first place, even if it is not 100% conclusive. For example, option A and option B can be explored and tested to reduce production cost without sacrificing quality. Analysts and business users should look to collaborate during the process. Also, when interpreting the results, consider any changes or limitations that may have not been present in the data. This will only increase the confidence in your previous steps. Now, what are the types of data analysis? The first one is descriptive analysis. The goal of descriptive analysis is to describe or summarize a set of data. It is the very first analysis performed. It generates simple summaries about samples and measurements, common descriptive statistics, etc. Just taking a small example, take the COVID-19 statistics page on Google, for example. The line graph is just a pure summary of the cases versus death and a presentation and a description of the population of a particular country infected by the virus. The next is exploratory analysis, which is also known as EDA. The goal is examine or explore data and find relationships between variables which were previously unknown. EDA helps you discover relationships between measures in your data, which are not evidence for the existence of the correlation as denoted by the phrase correlations does not simply imply causation. Useful for discovering new connections, forming hypotheses, and drives design planning and data collection. Considering an example, climate change is an increasingly important topic as the global temperature is gradually rising over the years. One example of EDA on climate change is by taking the rise of temperature over the years, say 1915 to 1920, for example, an increase of human activities and industrialization, and form relationships from the data. Example, increasing number of factories, cars on the road, and airplane flights increase, which correlates. Next is interferential analysis. Using a small sample of data to infer about a larger population, the goal of statistical modeling itself is all about a small amount of information to extrapolate and generalize information to a large group. The next is predictive analysis. Its goal is using historical or current data to find patterns to make predictions about the future. Accuracy of the prediction depends on the input variables. Accuracy also depends on the types of models. A linear model might work well in some cases and vice versa. Using a variable to predict another doesn't denote a causal relationship. Example, in 2020, US election is a popular topic and many prediction models were built to predict the winning of the candidate. And 538 did a great 2016 election forecast and is back at it again in 2020. Prediction analysis for an election would require input variables such as historical polling data, trends, and the current polling data in order to get a good prediction. Something as large as an election wouldn't just be using a linear model, but a complex model with certain tunings to best serve its purpose. Next is causal analysis. Its goal is to look at the cause and effect of relationships between variables, focused on finding the cause of a correlation. To find the cause, you have to question whether the observed correlations driving your conclusions are valid, as just looking at the data won't help you discover the hidden mechanisms underlying the correlation. Good data is hard to find and requires expensive research and studies. These studies are analyzed in aggregate, and the observed relationships are just average effects of the whole population. Next is mechanistic analysis. The goal is to understand exact changes in variables that lead to other changes in other variables. Considering an example, Many graduate level research and complex topics are suitable examples. But to put it in a simpler manner, let's say an experiment is done to simulate safe and effective nuclear fusion to power the world. A mechanistic analysis of the study would entail precise balance of controlling and manipulating variables with high accurate measures of both variables and the desired outcomes. It's the intricate and meticulous model strategy towards these big topics that allow for scientific breakthroughs and advancements in the society. Now, what is data visualization? Data visualization is the practice of translating information into a visual context, such as a map or a graph, to make data easier for human brain to understand and pull insights from. The main goal of data visualization is to make it easier to identify patterns, trends, and outlines in larger data sets. The term is often used interchangeably with others, including information graphics, information visualization, and statistical graphics. Data visualization is one of the steps of the data science process, which states that after the data has been collected, processed, and modeled, it must be visualized for conclusions to be made. Data visualization is also an element of the broader data presentation architecture, which is DPA discipline, which aims to identify, locate, manipulate, format, and deliver data in the most efficient way possible. Data visualization is important for almost every career. It can be used by teachers to display students' test results, by computer scientists exploring advancements in AI, or by executives looking to share information with stakeholders. It also plays an important role in big data projects. As business accumulated massive collections of data during the early years of the big data trend, they needed a way to quickly and easily get an overview of the data. Visualization tools were a natural fit. Visualization is central to advanced analytics for similar reasons. When a data scientist is writing advanced predictive analysis or machine learning algorithms, it becomes important to visualize the outputs to monitor results and ensure the models are performed as intended. This is because visualizations of complex algorithms are generally easier to interpret than numerical outputs. Now, as we got to know about this data visualization, we must know what are data visualization use cases, where all data visualization is used. So the first one is sales and marketing. Research from a media agency predicts that half of all the global advertising dollars will be spent online by 2021. As a result, marketing teams must pay close attention to their sources of web traffic and how their web properties generate revenue. Data visualization makes it easy to see traffic trends over time as a result of marketing efforts. Next is politics. A common use of data visualization in politics is a geographical map that displays the party each state or district voted for. Next is healthcare. Healthcare professionals frequently use chloropelt maps to visualize important health data. A chloropelt map displays divided geographical areas or regions that are assigned a certain color in a relation to a numerical variable. Chloropelt maps allow professionals to see how a variable such as mortality rate of heart diseases changes across different territories. Next is scientists. Scientific visualization, sometimes referred to in shorthand as CVs, also allows scientists and researchers to gain greater insight from their experimental data than ever before. Next is finance. Finance professionals must track the performance of their investment decisions when choosing to buy or sell an asset. Candlestick charts are used as trading tools and help finance professionals analyze price movements over time, displaying important information such as securities, derivatives, currencies, stocks, bonds, and commodities. By analyzing how the price has changed over time, data analysts and finance professionals can detect trends. Next is logistics. Shipping companies can use visualization tools to determine the best global shipping routes. Last is data scientists and researchers. Visualizations built by data scientists are typically for the scientists' own use. or for presenting the information to select audience. The visual representations are built using visualization libraries of the chosen program language or tools. Data scientists and researchers frequently use open source programming languages such as Python or proprietary tools designed for complex data analysis. The data visualization performed by these data scientists and researchers help them understand the data sets and identify the patterns and trends that would have otherwise gone unnoticed. Next, over to Sukanya.
Thank you, Parneet. Let's have a look at applications of data analysis. The number one is transportation. Data analysis can be applied to help in improving transportation systems and intelligence around them. The predictive method of the analysis helps find transport problems like traffic or network congestions. It helps synchronize the vast amount of data and uses them to build and design plans and strategies to plan alternative routes, reduce congestions and traffics, which in turn reduces the number of accidents and mishappenings. As you can see on the screen, the second one is logistics and delivery. There are different logistic companies like DHL, FedEx, etc. that uses data analysis to manage their overall operations. Using the applications of data analysis, they can figure out the best shipping routes, approximate delivery times, and also can track the real-time status of goods that are dispatched using GPS trackers. The another one is web search or internet web results. The web search engines like Yahoo, Bing, Google uses a set of data to give you when you search a data. Whenever you hit on the search button, the search engines uses algorithms of data analysis to deliver the best searched results within a limited time frame. The set of data that appears whenever we search for any information is obtained through data analysis. The fourth application is manufacturing. Data analytics helps the manufacturing industries maintain their overall working through certain tools like prediction analysis, regression analysis, budgeting, etc. The unit can figure out the number of products needed to be manufactured according to the data collected and analyzed from the demand samples and likewise in many other operations, increasing the operating capacity as well as the profitability. The another application is security. Data analyst provides utmost security to the organization. Security analysis is a way to deal with online protection zeroed in the examination of information to deliver proactive safety efforts. The another and a very important application is in education. Data analysis applications in education are the most needed data analyst in the current scenario. It is most used in adaptive learning, new innovations, adaptive content, etc. The another application is healthcare. You all must be wondering that how data analysis can be used in healthcare. So here is the answer for all your questions. Applications of data analysis in healthcare can be utilized to channel enormous measures of information in seconds to deliver treatment choices or answers for your illnesses. This won't just give precise arrangements dependent on recorded data, yet may likewise give accurate answers for exceptional worries for specific patients. The another application is in military. Military applications of data analysis bring together an assortment of specialized and application-situated use cases. It empowers chiefs and technologists to make associations between information investigation and such fields as augmented reality and psychological science that are driving military associations around the globe forward. The another one is in risk detection. One of the first data analysis applications may have been in the discovery of fraud. Many organizations were struggling under debt and they wanted a solution to this problem. The another application is risk management. It is essential aspect in the world of insurance. While a person is being insured, there is a lot of data analytics that goes on during the process. The another application is in interaction with customers. In insurance, there should be a healthy relationship between the claims handlers and customers. Hence, to improve their services, many insurance companies often use customer service to collect data. Since insurance companies target a diverse group of people, each demographic has their own preference when it comes to communication. The another and the last application is planning of cities. One of the untapped disciplines where data analysis can really grow is city planning. While many city planners might be hesitant towards using data analysis in their favor, it only results in faulty cities riddled congestion. Using data analysis would help them in bettering accessibility and minimizing overloading in the city. Now, data analysis software and tools used. To be able to perform data analysis at the highest level possible, we need data analysis tools. Some of them are here. The first is R programming. R is the leading analytics tool in the industry and widely used for statistics and data modeling. It can easily manipulate your data and present in different ways. It has exceeded SAS in many ways like capacity of data, performance, and outcome. So, what is the second tool on the screen? Yeah, it is Tableau Public. So, what is it? Tableau Public is a free software that connects any data source, be it corporate data, warehouse, Microsoft Excel, or web-based data, and creates data visualizations, maps, dashboards, etc. with real-time updates presenting on web. They can also be shared through social media or with the client. It allows the access to download the file in different formats. The another tool is Python. Python is an object-oriented scripting language which is easy to read, write, maintain, and is a free open source tool. It is easy to learn as it is very similar to JavaScript, Ruby, and PHP. Another important feature of Python is that it can be assembled on any platform like SQL Server, a MongoDB database, or JSON. Python can also handle text data very well. The another one is SAS. It is a programming environment and language for data manipulation and a leader in analytics, developed by the SAS Institute in 1966. SAS is easily accessible, manageable, and can analyze data from any sources. The another tool is Apache Spark. It is built on data science and its concept makes data science effortless. It is also popular for data pipeliners and machine learning models development. It also includes a library, MLlib, that provides a progressive set of machine algorithms for repetitive data science techniques like classification, regression, collaborative filtering, clustering, etc. The another very important tool is Excel. Excel is a basic yet popular and widely used analytical tool almost in all industries. It becomes important when there is a requirement of analytics on the client's internal data. It analyzes the complex task that summarizes the data with a preview of pivot tables that helps in filtering the data as per client's requirement. The another tool is RapidMiner. RapidMiner is a powerful integrated data science platform developed by the same company that performs predictive analysis and other advanced analytics like data mining, text analysis, machine learning, and visual analytics without any programming. The another one is NIM. NIM is leading open source reporting and integrated analysis tools that allows you to analyze and model the data through visual programming. It integrates various components for data mining and machine learning via its modular data pipelining concept. The another tool is ClickView. ClickView has many unique features like patent technology and has in-memory data processing, which executes the result very fast to the end users and stores the data in the report itself. Data association in ClickView is automatically maintained and can be compressed to almost 10% from its original size. Data relationship is visualized using colors. A specific color is given to related data and another color for non-related data. The another tool is Splunk. Splunk is a tool that analyzes and searches the machine-generated data. Splunk pulls all text-based log data and provides a simple way to search through it. A user can pull in all kind of data and perform all sort of interesting statistical analysis on it and present it in different formats. The another very important tool is Power BI. Power BI nowadays is a major data analytics software being used by leading MNCs around the globe. It is a Microsoft Business Analytics Service software. It provides interactive visualizations and business intelligence capabilities with an interactive interface. It is a collection of software services, apps, and connectors that work together to turn your unrelated sources of data into coherent, visually impressive, and interactive insights. Now, Jupyter Notebook. What do we understand by Jupyter Notebook? Parneet, please change this slide. What do we understand by Jupyter Notebook? Jupyter Notebook is an open source web application that allows you to create and share documents that contain live code, equations, visualizations, and explanatory text. Its uses includes data cleaning and transformation, numerical simulation, statistical modeling, and machine learning, and much more. Now, benefits of Jupyter Notebook. First one is it is easy to share. Notebooks are saved as structured text files JSON format, which makes them easily shareable. The another benefit is that it is easy to convert. Jupyter comes with a special tool NBConvert, which converts notebooks to other formats such as HTML and PDF. Another online tool, NBViewer, allows us to render a publicly available notebook directly in the browser. The another benefit is that it is language independent. The architecture of Jupyter is language independent. The decoupling between the client and kernel makes it possible to write kernels in any language. The another one is that it is easy to create kernel wrappers. Jupyter brings a lightweight interface for kernel languages that can be wrapped in Python. Wrapper kernels can implement optional methods, notably for code completion and code inspection. The another one is that extensions with custom magic commands. Create IPython extensions with custom magic commands to make interactive computing even easier. Many third-party extensions and magic commands exist. For example, the Python magic that allows one to write Python code directly in a notebook. The last but not the least benefit of Jupyter Notebook is that it is effective teaching cum learning tool. The Jupyter Notebook is not only a tool for scientific research and data analysis, but also a great tool for teaching. An example is IPython blocks, a library that allows us to create grids of colorful blocks. Now I am writing a link in the chat box. As you enter this link in your browser, this interface will open up. On scrolling down, click on Try it in your browser. You can also download Jupyter Notebook in your desktop. Then Try Jupyter Lab. It will take a bit. Now click on Python 3 to open a new notebook. Since it is untitled, I will rename it. So this was the first way to open a new notebook. Now I will tell you the another way. Go to File, then New, then go to Notebook. Then select Python 3 as your kernel. Now this is the another way to open a notebook. Now I will tell you some features of this Jupyter Notebook. This icon saves the notebook contents and create checkpoint. This one inserts a new cell below. It cuts the selected cell. It copies the selected cell. This icon pastes cell from the clipboard. This one runs the selected cell in advance. It interrupts the kernel. It restarts the kernel. It restarts the kernel, then rerun the whole notebook. Now I will write a small Python program to show you how that it runs. Now I will run it. So as you can see on the screen, we have got a desired output. Now we can also insert a new code cell on clicking on this icon. See, I will write another code. Okay, suppose I want to store variables value in this array. If I run this code snippet for once, it is done for throughout the code. There is no need to run this part again and again. As we can see on this screen, values from 9 to 1 as per the definition of the range function. Now there is a section here which itself has 3 sections. So first is code. Whenever we want to write a code and want its output, we write it under the code. Now markdown. What if we want to write a comment? Then we choose the markdown section. I will write here comment. I have written here this under this markdown section. I will run it. So as you can see, it has become a comment. Now, what if I want this comment in bolder and larger size? I will use HTML tags here. I will select it under the markdown section. Then run it. So as you can see, it is bolder and larger in size than the previous one. And what if we just want it to get bold and not increase its size? Then we can use strong instead of H1. selecting Markdown. Now running it. So as you can see, the size is similar to the previous first one, but it is bolder. We can use all the 6 HTML tags for comments here in the Markdown. All the 6 HTML headings and text features are applicable same as of HTML. This is valid for the comments only. Now the third one is row. Right now I'm selecting code. I have selected it under the code section and now I will run it. So we have got our desired output, which is odd, because it is a program which simply tells that whether I is odd or even. Now, what if I just want this code snippet in our entire file but don't want it to get run? So I can write it under the row section. I'm copying the same program and running it under the row section. So as you can see, we have not get our output. So this was the function of row. Now I will tell you how to import libraries. For example, I want to import pandas, then I will write like import pandas as any shortcut that we want for pandas so that we can access pandas through that shortcut for our entire code. I am using PD here. Then run it. So for now, for the entire file, pandas will be imported as PD and we can access it throughout the code. Now there is an option of making a new folder by double clicking on this icon. I am renaming it as student. Now on double clicking on this folder, I can add files into it by dragging and dropping. So yeah, I have uploaded my Jupyter notebook and CSV file in the folder. As I double click on the Jupyter notebook, we can walk through our existing file and Jupyter notebook already runs all this cell to show us the result. Now this is the CSV file. This is basically the data set which we all be using for data analysis. As you can see, there are different columns and a lot of rows. Now coming back to this notebook. Now you can download this notebook from here. You can store it to browser storage from this icon and you can restore it from browser storage by this icon. This icon helps in visiting binder repository and this one is the link to this binder. So this was all about Jupyter Notebook. Now I would like to call Soumya for further presentation.
So let us first come to what are functions in Python, or what do you understand by functions? A function is a block of organized, reusable code that is used to perform a single or related action. Functions provide better modularity for your application and higher degree of code reusing. As we already know, Python gives us many built-in functions like print, etc. Now, Python has a lot of functions, but we do not have to learn about all of them. So we would stick to data analysis and learn about the functions majorly used in them. The first on the screen is read_.csv. Read_.csv is an important pandas function to read CSV files and do operations on it. Opening a CSV file through this is very easy. For instance, one can also read a CSV file, not just locally, but also from a URL through read._csv. We can also specify a file name to pandas.read_csv. Then Python starts to look into the current working directory. Now, what do you understand by current working directory? Your working directory is typically the directory that you started your Python process or Jupyter notebook from. The next on the screen is dtype. Every ND array has an associated data type, which can be written as dtype. This data type object informs us about the layout of the array. This information, this dtype array gives us a few information. That is, first, type of data. That could be integer, float, or Python object. Second is the size of data, that is number of bytes. Third is the byte order of the data. And the fourth is if the data type is a subarray, and if it is a subarray, what is its shape or data type. Now let's come on to the third function, that is describe. Pandas describe is used to view some basic statistical details like percentile, mean, average of a data frame or a series of numerical values. When this method is applied to a series of string, it returns us a different value. The fourth on the screen is df.head and df.tail. Starting with df.head. To view the first 5 rows of the data frame starting from 0 to 4, we use df.head in Python. To override the default, you may write a value between the parentheses to change the number of rows returned. For example, if I write df.head and in parentheses I write 12, it would return me 12 rows. For example, if I use df.tail, it gives me the last 4 rows, the last 5 rows starting from the last number to the decreasing order. And in the same way, if I write df.tail and in parentheses I write 10, it would return me the last 10 rows. The next function you can see on the screen is df.groupby. It is a very important function in Pandas. Pandas data frame.groupby function is used to split the data into groups based on some criterion. Pandas object can split on any of their axes. The abstract definition of grouping is to provide a mapping of labels to group names. A group by operation involves some combination of splitting the object, applying a function, combining the results. This can be used to group a large amount of data and compute operations on them. The last function we would be learning is the len. The Python len method is a built-in function that can be used to calculate length of iterable objects. So if you want to get the length of a string or a list dictionary or another iterable object in Python, the len can be the most useful. When the object is a string, the len function returns the number of characters in the string. The next we have is graphs in Python. Now the basic question is, do you understand the term graph? A graph is a pictorial representation of a set of objects where some pairs of objects are connected by links. The interconnected objects are represented by points termed as vertices, and the links that connect these points are called edges. The first graph on your screen is a histogram. The histogram represents the frequency of occurrence of a specific phenomenon which lie within a specific range of values and arranged in consecutive and fixed intervals. The second graph we'll be learning about is a box plot. A box plot is a graphical representation of statistical data based on the minimum, first quartile, median, third quartile, and maximum. The third on your screen is a column chart. A column chart is used to show a comparison between different attributes or it can show a comparison of items over time. Now, the most famous to us is a pie chart. Now, what is a pie chart? A pie chart shows a static number and how categories represent part of a whole composition of something. A pie chart represents numbers in percentages and the total sum of all segments needed to equal to 100%. The next graph is a scatter chart. A scatter chart shows the relationship between two different variables. It can reveal the distribution trends. It should be used when there are many different data points and you want to highlight the similarities in those two data sets. The second last one is the area plot. The area plot is also known as the stack plot. It is quite similar to the line plots. Area plots are used in tracking the changes over time for two or more related groups that make one whole category. The last graph for the day would be the line chart. Line charts are used to represent the relationship between two data, X and Y, on different axes. Now, coming up to libraries. Do we all understand what a library or what is a library in Python? Python libraries are a set of useful functions that eliminate the need of writing a code from scratch. There are about 137,000 Python libraries available. Now we will be learning about a few of them which are most useful for data analysis. The first on the screen is Pandas. What is Pandas library? Pandas library is a machine learning library in Python that provides data structures of a high level and a wide variety of tools for analysis. One of the greatest features of this library is the ability to translate complex operations with data using one or two commands. The second you can see is matplotlib. Matplotlib is an amazing visualization library in Python for 2D plots of arrays. Matplotlib is a multi-platform data visualization library built on NumPy arrays and designed to work with broader SciPy stack. Now, what is the SciPy library? SciPy library is a machine learning library for application developers and engineers. SciPy library contains modules for first, optimization, second, linear algebra, third, integration, and the last is statistics. The next library you see on the chart is the NumPy library. NumPy library is one of the most popular libraries. TensorFlow and other libraries use NumPy internally for performing multiple operations on tensors, array interface, and array interface is the best and most important feature for this NumPy. Now, what do we understand by TensorFlow library? TensorFlow library works like a computational library for writing new algorithms that involve a large number of tensor operations. Since neural networks can be easily expressed as computational graphs, they can be implemented using TensorFlow libraries as a series of operations of tensors. The last library is the PyTorch library. Now, what is a PyTorch library? PyTorch library is the largest machine learning library that allows users to perform tensor computations with acceleration of GPU. This creates a dynamic computational graph and calculate gradients automatically. Now, let's see the project implementation where we'll be using all the functions, libraries, and the different aspects of Python. I'll share my screen. I'll be using Anaconda. It is a GUI interface, and that has a lot of options like the prompt or the Jupyter Notebook. So I'll be sharing the Jupyter Notebook. So as Sukanya explained you about the Jupyter Notebook, I would start with the code. So first of all, the first key feature to start with the code is to import libraries. So I would import the libraries. I'll write import pandas as PD. Now, when I write import pandas as PD, since I cannot write pandas again and again when I'll be using this library, so I give it a short name so that it's easier for me to write my code. Next is import matplotlib.pyplot. Make sure you write the correct name of library because otherwise the library would not be imported. Now, matplotlib is used for the visualization as discussed earlier. The last I'll be importing is Seaborn library as SNS. Now I would run this, but we would not get any output because it's just importing the library into my notebook. Okay, now first of all, I'll write the code to see my data set or my data. So I'll use df. df stands for data frame. Data frame is equals to pd.read underscore CSV. I told you about this function. This reads the file. And name the CSV file I've used. I've used it by the name of students performance. Make sure you write the exact name, else it would not get be printed. Now df, I'm calling the function and I'll run this. Hold on a second. Okay, I have not written the extension. That's why it's showing me the error. Make sure you write the extension of your file. Now you can see, I'll zoom out so that you can see it completely. So you can see my CSV file got printed, but is not showing me the complete file because it does not have so much space. So it just printed the first 5 rows and the last 5 rows, but it is telling me that it has 1000 rows and 8 columns. Now I would again zoom and I would now write the code to show the number of objects. Like I'll write the code df. I'll use the another cell. I'll write df dot select underscore the types and object, then n unique. Now, what is this code doing? I have used the function select underscore dtypes, which I also explained in my above presentation. And I have told her that I have to use objects, and then I've used the call as n unique. Now, what this n unique does, it has now seen that what kind of objects or entries I have in my data. It is gender. And as in the graph above, we know gender was of basically 2 types, male and female. So it has counted the unique kind of repetition, and it's 2, male or female. Then it's race and ethnicity. It is showing me 5 because there are 5 kind of groups used in the above CSV file. And it is same for the other things. Parental level of education 6, lunch 2, test preparation course 2. Now I would use the another code, and in this I would tell how can we group. We used a group by function. Now I'll be using this group by function here in the code to tell how we can group the data by these similar aspects, and then use it to find mean, median, average, maximum score, minimum score. So I'll write df dot group by square brackets. I'll do it on the basis of gender. So I'll write gender here. And I'll do what kind of output, on what basis do I need this gender to be grouped. So I'll do it aggregate brackets, square brackets, and I'll do it on the basis of minimum. And next I'll take as median. And next I'll take as maximum. Now I would run my code, and you do not have to import the files again and again. Once the libraries are imported, it would show the outputs. See, gender, female, male, my math score, reading score, and writing score on the basis of minimum, median, and maximum as we used for the code. Like we grouped gender on the basis of minimum, median, and maximum scores. Now let's try to make a graph. Now for graph, I would first show you the graph that how can we analyze the number of males and females whose entry we have here with us. So I'll use matplotlib library. So I'll be starting my code with PLT because I imported it as PLT. So PLT, RC, parent. Now RC is runtime configuration and parent stand for parameters. I'll put a square bracket. And on what I would specify here is figure, and I'll use figure size. Now I would specify what should be the figure and figure size. I'll do it as 15 and 5. Now the second would be I'll use the what kind of style do I need here. So I'll do style use, and I'll use a name, and I'll use classic test. Now these names are already given in your libraries. You have to just see which color or what kind of color or what kind of plotting do you need, and you use these styles accordingly. It's all given in the libraries. And I'll use classic underscore test. Next, the important thing is on the what basis do I need the plotting. Here I would use my Seaborn library as SNS. So NSS dot count plot, then df function. Df is data frame. It stands for data frame. I'll use square brackets. I'll tell I'm doing it on the basis of gender. And then I'll use the palette. What does palette stands for? The color. Like what color plots do I need? So I'll use it as bone. Also going. Now I'll be using what I have to give the title for my plot. I'll again use the matplotlib library, plt title. See, I was making an error since the inverted commas weren't put, so I have to make sure that everything is done. Now plt dot title, and then I'll use the heading. I'll put it as comparison of males and females. Done. And now I'll tell about the font size or font weight. And I want that as font weight is equals to 40. Now I would tell what I need it as X label. So plt dot X title, sorry, X label, what I need in the X axis. I want it as gender. And plt dot Y label. And on Y label, I will use it as count, the number of students. And the last is plt dot show, so that it prints the graph. Now I'll zoom out so it's visible. Now I'll run this. And as you can see, we've got a graph where it is doing a comparison of males and females. As we told it that Y label should be count, X label should be gender, and we use the color palette as bone. So it has made a graph on the basis of that. We can say the number of females are more and males are less. We can take example of one more graph. And how do we decide what kind of graph it has to be? I've specified here in parameters, figure size, figure, and I've used the style. I have defined everything here. So it's the every output you give is shown to you as output. Now let's see one more graph, and I'll do it on the basis of math scores. How did the students score in their maths? I'll zoom in again so that the code is readable. Okay, I'll use again matplotlib library, RC parameters. And then I'll again put square brackets. And I'll use figure and figure size to specify figure and figure size. And do make sure that you write correct spellings, otherwise it would not print your output. I uses 15 and 5. Then I'll use again matplotlib library to talk about the style used. I put it in round brackets. I'll be using this time Tableau, color, blind, 10. Next, I'll be using Seaborn library again for the count plot. DF. DF, again, I'm repeating, is for data frame. I'll use math score, as I mentioned before. Math score. And then I'll use a palette, the color palette. And this time I'll use a different one. It is BU, PU. Make sure when you extract the what kind of palette, what kind of style you're using, make sure you write the correct name. Now again for the title, tlt.title, and I'll use comparison of math scores. Now I'll specify the font, weight, and we'll this time take it to be 20. And also the font size, that is 20 again. Now I'll write about the X label, Y label, as we wrote earlier. X label, it would be used as score. For Y label, I'll use it to be count. Now, I'm using a new function here. Just look at that, x, and in brackets I'll write rotation equals to 90. Now what does this mean? X6 rotation equals to 90 means that my x-axis, the label of x-axis would come at 90 degree to the Y label. And last would be the show to print my graph. In parentheses, it's done. I would zoom out. And now I'll run this. We made an error. Okay. We have, we'll just recheck it. Platlib RC parents, and I've used figure and dot fig size in, okay. And I have put the values as 15 and 5. The next is plt.style.use. I've used Tableau, colorblind 10, then SNS, count, plot, and then df, math score. Palette is used as Boku, and then plt.title, comparison of math scores, font weight, font size, plt.x label is used as score, plt.y label is used as count, plt.xtext rotation, I have used it as 90. Now plt.show, we'll run this again.
Maybe Soumya, we have to remove the parenthesis after show, plt.show. You did not use it before. But in this
No, plt.show has parentheses. I'll just correct the code.
Well, it says match score. It has error with match score. So
Yeah, it has mattered with
is it?
math score because I've used S and the correct file did not have S with it. So I'll just make the correction. See, I would have to use it as math score because the original CSV file did not have it written as maths and it was math. So we'll run it and we can see that we have got the comparison of math scores. These are the scores written and the count shows the number of students scoring the same score. So it's like if we just go to 60, we can see that 17 students have got 60 marks, and this is how the visualization is done. Now I can show you more graphs that have been made. I'll zoom in so that you can see the graphs. So here is some comparisons made on the basis of maths, writing, and reading score. And now you will see it's math written. I have to make sure that I write the correct name, because if I just put an S or any word extra, it would not be able to bring it up from the CSV file as it reads the data from CSV file. So I have to make sure that everything is written correctly. This is the comparison of males and females, the graph which we made. This is the comparison of groups. These are the number of groups written on the x-axis, and the y label has the students in that particular group. Next is comparison of parental level of education. The number of students who have parents with bachelor's degrees around 125, and it is so on. Next is comparison of different types of lunch. I'll zoom out, but it's easy. You can say it's on the basis of lunch, that how many students get standard lunch, how many gets free and reduced lunch, the graph for that. It's the comparison of math score, which we just made. Next is comparison of reading score, how many students are scoring the marks according to the reading. Then it's writing scores. It's the total number of scores, like total number of students scoring the total score. It's the graph for that. It's gender versus race. Then we have race versus parental level of education. And this is at the last, this is the pie chart in which the total different groups in a pie chart. That's all. Thank you.
So for any doubts, you can contact any one of us on this email IDs, Also, you can ask any questions here, if any. Also, we'd like to acknowledge the support and mentorship of Sudhakar sir throughout the project. We have also, if you have any such projects in your mind, you can contact him using the details which I'll be giving in the chat box. So go ahead with your questions.
I had a few questions. So, Sukanya mentioned about Jupyter Notebook. Sukanya, can you tell me certain alternatives apart from Jupyter Notebook that I can use for work in Python or C?
Yeah, there are many top alternatives to the Jupyter Notebook. Some of them are Eclipse, PyCharm, AWS Cloud9, Kite, Selenium IDE, Wing Python IDE, CodeEnvy, and Spider Download.
Okay. Have you worked on any of them apart from Jupyter Notebook?
No, I have just worked on Jupyter Notebook.
Okay. And one question for Soumya. How do you decide which graph to choose, for which data set or column? How do you decide that?
Yeah, we decided in the, as you must have seen, that I mentioned using the library PLT, and then I was telling the style used, or I was telling the graph, or like I was using figure size, figure. It is all used to describe how can we use a different kind of graph. Maybe a histogram, maybe a line plot, it could be anything else. And if in case we want to construct a histogram, then we decide the number of bars and intervals too. Like we look out for which graph are we presenting, and then we have to make sure that we specify each and every kind of detail needed for that graph.
Okay, so if there are certain number of groups, will pie chart be a good option to go for?
If they're total, for the pie chart to be used, you have to make sure they're from the similar category. Like if I am using a pie chart for groups, the total number of, like I use the data for 100 rows. That means the total strength is 100, like it's, sorry, 1000. Then the distribution of groups, like it can be used for a pie chart. Like it can to bring up, like it would serve your CSV file to see how many students come under group A, group B, and accordingly the groups divided, and it would give the division accordingly. You just have to make sure, like, just I was having an issue of plotting because I used the wrong word. So it is very important that I write the correct group name, and I write exactly as written in the CSV file, so that it's easy for this the Jupyter notebook to read the file.
Okay, all right. Thanks. Anything else from you guys, or Shreya, over to Shreya?
Thank you so much.
So thank you for an astonishing presentation and demonstrations to all the speakers. The audience definitely would have gained a better understanding of different tools and techniques involved in data analytics. Thank you once again, guys. So after this, right now,